Welcome to the Math Record. Today I'll be covering the ICTM Regional 2016 Division AA Freshman Sophomore 8-person, which I'll be covering questions 13 and 18. Okay, as usual, I'll scroll down all 20. Okay, now let's begin with number 13. In the right triangle EBM with the right angle at B, points G and O trisects MB while points L and U trisects EB. ML equals 8 and OE equals 6. Determine the length of ME. Okay, so let's kind of draw this. And flip this over to the side. Okay, and we have some points of trisection. So we have a point here, 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 and here. Okay, let's move this over a bit. So we could call this our length, and we call this our height. And then we have ML. So I'll just put that in red. So ML. So from here to here, that is length 8. Okay. And now let's use blue. And we have OE is equal to 6. So this is equal to 6. So we had these two lengths. So how do we find our length for our hypotenuse? Okay, so we need to find this length over here. So what I notice is, since this is a right triangle, well, we could just say this is 1/3 of the height. So 1/3 of height squared plus our length squared is equal to our blue line, because that's just a triangle, so that's 6 squared, which is 36. Now, if we do for the red one, we have height squared plus 1/3 of our length squared. That is equal to 6 squared, which is 64. So if you write that out, that's just 1/9 h squared plus L squared equals 36. And then h squared plus 1/9 L squared is equal to 64. And you add them together, that is 10/9 h squared plus 1/9 L squared is equal to 100. So, oops, sorry, 10/9 L squared equals 100. So we could just multiply both sides by 9/10, so that gives us h squared plus L squared, which is what we want to get our question mark, that length. Then that will become 90, right? So to get the hypotenuse, we had to take the square root of that. So square root of 90 and divide out the 9, which is just 3. So it's going to be 3 square root 10. And that is your answer for number 13. And that's basically all you have to do. Okay, number 18. A regular octagon is inscribed in a circle with radius with diameter 8. A square is inscribed in the same circle, so the vertices of the square are also vertices of the octagon. Determine the exact area inside the octagon but outside the square. Okay, so let's kind of draw a diagram of this. So we have some kind of circle. Let's make this bigger. I'll just put it to the side if we had to do any math. And then we have our octagon. A little bit bigger. And then we have a square that's so here. So basically what we had to do is kind of line it up a bit bigger. Smaller. And a bit smaller. Okay, so something like that. So we have this square, we have this octagon, and we have this circle. So what we could do is that we just do some lengths. So they want to find the area that's inside the octagon but outside the circle. So basically this area, right? All that area that's inside the octagon but outside the circle. I mean outside the square. So we draw the center of our circle. We know that's diameter 8, so the radius is going to be 4. So this is 4, and this is 4. And now what we could do is that we could kind of draw a length from here to our to this point, right? So it cuts it in half. And since this is a square, this is 45 degrees, and this is 45 degrees, and this is 90 degrees. So that gives us that this length is just 4 times square root 2. So it's going to be 4 square root 2. And since we cut it in half with this line, that means this length is 2 square root 2, and this length is 2 square root 2. Okay, now what is this length? Well, if we cut it in half right here, this is going to become a 90, and remember this is still 45, so that means this is 45. So going by the 45, 45, 90 triangle, this length also has to be the same length as this because this is isosceles. So that gives us that this is 2 square root 2 again also. Now we need to get this length right here. So we could just use inscribed angles and lines. So I know that this is length 4. So we could just say 4 plus 2 square root 2 times this length, which I'm just going to call x, is equal to 2 square root 2 times 2 square root 2. So that is 8. So we just divide 2 from both sides. So that makes 2 plus 2 square root 2, x equals 4. So 4 divided by 2 plus square root 2. So 2 minus square root 2, 2 minus square root 2. We need to rationalize the denominator. So 2 times 2 is 4. And then square root 2 times square root 2 is negative 2. So then 4 minus 2 is 2. So 4 divided by that 2 is 2. So on the numerator, we have 2 times 2 square root minus square root 2. So that would be 4 minus square root 2 is equal to our x. So we have this length, which is 4 minus 2 square root 2. Okay, and now we have everything we need to find the area. Because the area is just base times height. Our base is 4 square root 2, and our height is 4 minus 2 square root 2. And then multiply by half because it's a triangle. And then since there's 4 of them, we need to multiply by 4 also. Okay, so cancel out this 4 and this 1/2 to make a 2. So 4 times 2 is 8 square root 2 times 4 minus 2 square root 2. So that is 32 square root 2 minus 16 times a 2 is minus 32. So that is your area, 32 square root 2 minus 32. And that's also your answer for number 18. Well, actually, here are the answers first. And thanks for watching, and I'll see you at the next math record.